volumes of three-dimensional shapes. So in this lesson we will be looking at volumes of three-dimensional shapes, and in fact in this lesson and in the following lessons we will be looking at calculating the volume of three-dimensional shapes. So I think to begin with, I think it would be a good idea to go over some of the formulas, the common formulas of common three-dimensional shapes. So let's begin with a cylinder. Okay, so on a sheet of paper, once again, make sure you make some space, and as always, you're welcome to pause the video in order to take notes. Let's begin. So you have a cylinder. It has this shape like a can, and this R represents the radius of the cylinder and H the height. So what is the formula for the volume of a cylinder? It's simply volume equals, so V equals pi R square, which is the area of the base times the height. Alright, so that's the formula for the volume of a cylinder. Let's take a look at another shape here, and in fact let's write down here sphere. So let's take a look at the formula for the sphere. Now let's draw a sphere. I'm going to try my best. I'm not very good at this, but I'm going to try my best. So, and there's the radius. Okay, and now the volume of a sphere, the formula for the volume of a sphere is V equals 4/3 times pi times r cubed, or you can also write it this way. You can also write it as 4 pi r cubed over 3. It's all the same. Okay, let's take a look at our next shape, the cone. The cone. Okay, let's begin with this, the cone. So once again, I draw my base here like this. Okay, so from there to there we have the radius, and here's the height, and S stands for the slant height. Okay, so here we have R is for the radius, H is for the height, and S is for the slant height. And the formula for the volume of a cone is equal to V equals 1/3 times pi r squared times height, or, right, you can rewrite it this way too, pi r squared times the height divided by 3. So you may already start noticing some patterns between the prisms and the corresponding pyramids. We will talk more about that in future lessons. Let's take a look at another shape. This would be a square-based prism. Okay, so we have this, and this side length is equal to B, this one's equal to B, and then we also have a height, which I'm actually gonna do in a different color. It's from there, just so that it is more visible and not as confusing. Alright, so that's gonna be our height, and S will be our slant height. Slant height is basically the length of the side, right? The length of the side. So from there to there. In fact, let's do that in a different color. And you can do it like that on your notes as well. So it goes on this side, and we'll see. We might need it for some examples. So that's going to be S. Very similar to the cone, right? That's the slant height. Okay, so what's the formula for a square-based prism? Well, the formula for a square-based prism is same idea. We have 1/3 times the area of the base, which is B times B. That gives us the area of the base, B squared, times the height, and times 1/3, or, as you can expect, same idea. It's like saying B squared times height divided by 3. And let's take a look at two more shapes here. So make sure you pause the video and get notes for this. Let's take a look at two more shapes. These shapes are the rectangular prism. Okay, so we have our prism here, and this will be our height, our length, and our width. And by the way, all of these are of course 90 degrees. So what's the volume? What's the volume of this rectangular prism? Well, the volume is going to be, we are very familiar with this shape, so length times width times height, right? So length times width times the height. Okay, in other words, the area of the base times the height. And our last shape here, let's do a triangular prism. Now you have this triangular prism, which is essentially looks like a tent. Now you have this height here. This height is the height of the triangle of the base, not the height of the actual prism. So that's important to recognize, that many people mess up on this. So let's call this height L. This is the height of the base of this triangular prism. Okay, and let's call this B, which is essentially just the side length of the base. And this will be our height. Our height. And of course, this would be A, because we don't know whether it has the same length as B. And this would be C as well. Okay, and so what's the formula for the volume of a triangular prism? It's equal to, well, volume is equal to, you can say 1/2 times base times L, which is this one over here, times the height, which is this, which is essentially the area of the base times height divided by 2, so B times L divided by 2 times the height, right? And of course, this is another way of writing the same formula, B times L times H over 2. Okay, so make sure you have this on your notes, and let's take a look at other lessons. Oh yes, and just to clarify a little bit more, I almost forgot, sorry. So this triangular base prism is just like this. We're all familiar with a Toblerone, and so the L right here, the height of the base is basically this. If you can see, this is the base. I hope you can see there with the light. That's the base. This is the value of L. This L right here is actually this. This L right here is actually this. In fact, let me use the other side. This L right here is this height. Right? Maybe you can see it there. There. Right? This height over here, the H, is actually this. It's actually, and I labeled it here. Not that I'm making an ad or I'm being sponsored by Toblerone. But here's the height, right? Height is from there to there. That's the H value. Okay, so always keep that in mind when you are presented with a triangular prism problem. The difference between H and L, the difference between the two heights.